morning, guys. Morning. Online students, am I audible? Let me know. Okay, any doubts from yesterday? Everything clear? Good morning. कल हम लोग कहाँ तक थे? Properties of exponents. We were starting that. Comfortable with everything, na? Operations. You can multiply two numbers even if they are large. You can multiply decimals, divide decimals. All those skills, basic skills, you are comfortable with. And now we'll do properties of exponents or powers. We studied something. We defined powers yesterday as x raised to some m is equal to x into x m times. Powers were nothing but repeated multiplication, just like multiplication was repeated addition. It was powers. So now there are some basic properties of powers which we should be comfortable with. They are very easy to prove. They follow from this directly. For example, a raised to m into a raised to n. What is this? A raised to m plus n. Why? This is a into a m times, and this is n times. Total, how many times multiplication is there? M plus n times. Simple. Then other powers, division. Division is just reverse of addition, multiplication. So division would be a raised to m divided by a raised to n, a raised to minus n, right? Then a raised to 0 is 1 for all a's. Doesn't matter if the a is natural, whole, real, rational, irrational, imaginary, anything. A raised to 0 is 1 and a raised to 1 is a. This is by definition. We define a raised to 0 to be 1. Then a raised to minus 1 is nothing but 1 by extending. Then a raised to m raised to n is a raised to mn. How can you see this? This is nothing but a raised to m into a raised to m into a raised to m n times, and each a raised to m is what? A into a m times. In total, how many times a comes here? M plus n n times. Basically, it repeated addition. What is repeated addition? Multiplication. It's nothing but a raised to mn. A will come mn times in this product, right? So if I put m is equal to minus 1, then I get a raised to minus 1 raised to n is equal to a raised to minus n. So what is this? This is 1 by a raised to n. This is 1 by a raised to n. 1 raised to n, a raised to n, 1 raised to n is just 1. 1 raised to anything is 1. It doesn't matter how many times you want to multiply 1 or take root of 1, it's just 1. Even if you don't remember how we are arriving at this, at least remember the result. This is the result. The result is equal to 1 by a raised to n. Then AB raised to n is a raised to n, b raised to n. Power of product is product of powers. And then division के लिए same, a by b raised to n. Division is nothing but reverse of multiplication, a raised to n by b raised to n. And then root is there, a raised to 1 by n is nth root of a. N can be anything, right? If we are talking about square roots, that would be 2. If we are talking about cube roots, this would be 3. Square root is represented as this, cube root is represented as writing 3 outside the radical sign. This is cube root. You can write here 4, 5, 6. I have written here n, which means that this is the nth root of that particular number. Similar rules follow exactly in this matter, exactly in this pattern for fractions as well. So it doesn't matter here a is uh, integer or rational number, all the rules will stand. For fractions, I have written all these rules in the fraction section. For fraction, we'll study addition, multiplication, division, etc. of fractions separately as well. But these are the rules which follow like that in the fractions as well. The next, you are comfortable with all these rules? You knew all these rules beforehand as well? These are just standard rules which we use when we are dealing with exponents or powers, right? You can take any numbers and for the sake of practice and try to deal with all those rules. Just 1, 2, 3, 4 raised to 1, 2, 3 raised to 4 into 1, 2, 3 raised to 50. What would be this? 1, 2, 3 raised to 54. Exponent just power gets added. 1, 2, 3 raised to 4 divided by 1, 2, 3 raised to 50. What would be this? 123 raised to division 4 minus 50, which is minus 46, equal to 1 by 1, 2, 3 raised to 46. Whatever that number is, we are not interested in that. Then 1, 2, 3 raised to minus 4 divided by 1, 2, 3 raised to 50. What would be this? 123 raised to minus 4 minus 50. Minus 54. 4 minus 50. Minus 54 is 1 by 123 raised to 50. All these rules operate like this. One more. 123 raised to 123 cube raised to minus 2 into 123 raised to 5 raised to 1 by 15 raised to 1 by 3 to 123 raised to minus 3 divided by 123 cube. Or let's say 30. Otherwise that would get 10. What will be this? Base is same. Base is everywhere 123. So that is not a problem. So in answer as well, we'll have base 123. Here, what is this? 123 raised to 123 raised to cube raised to minus 2. ये वाला प्रॉपर्टी यूज करना, a raised to m raised to n is equal to a raised to mn वाला चीज. So these two just numbers multiply these two numbers. Minus 6 positive into negative is negative. This minus 6 into 123 raised to these two numbers multiply. 15 into 1 by 3, 5, 3 5s are 15, right? Into 123 raised to minus 3, it is like that, into 123, no sorry, it is divided by 122, 123 raised to 30. So this is minus 5 plus, sorry, minus 6 plus 5 minus 3 minus 30. This is division, so things get subtracted. This is multiplication, things get added like that. The same as 123 raised to, what is this? Minus 1, minus 3, minus 4, minus 34. Right? Minus 30, and this is minus 6 plus 5, minus 1. So minus 1 plus minus 3, which is minus 4. Minus 4 minus 30 is minus 34. This is how you deal with exponents. Clear? You can take few more questions on your own. Just take any random numbers, frame the questions like this and practice. If you want, I can just write 2 questions right now for you to practice at home if you want, or if you are comfortable, we can move on. कर ही लो यार क्वेश्चन, 5 क्वेश्चंस कर ही लो, इतना ही टाइम. Okay, write down these questions, then I'll repeat. कर लोगे ना ये सब? हाँ हाँ, लिख लिया. Okay. Vic, what we did here was we wanted to get familiarized with all the rules for exponents, all these rules. So we are taking one example. I hope these examples were clear, where multiplication is direct, like a raised to m into a raised to n is simply a raised to m plus n. That rule was directly applied for this. For this, division wala rule was directly applied. Now, for this particular question, we firstly observe that base is everywhere same. Because base is same, we can just deal with powers, and we wanted to simplify the powers using this particular property. 123 raised to 3 raised to minus 2 would be just 123 raised to multiplication of these two numbers, and 3 into minus 2 is minus 6. Similarly, here 123 is there, and 15 into 1 by 3, 15 into 1 by 3 is nothing but 3 1 the 3, 3 5 are 5, which is 5. So this 5, 123 raised to 5 comes here. Then next is minus 3, that comes directly, and next is 30, that comes directly. It is in the division. And because base is same, we can just add or subtract powers according to whether we have multiplication or division. So I did that. 123 raised to minus 6 is multiplication. So first plus 5 minus 3 Again in the multiplication, so we add powers using this particular property, and because this is division, we subtract power. This is 30, so we subtract 30 from whatever we have earlier. So we simply add this, it comes out to be minus 34. Answer is this. I hope it is clear now, Vivek. The next है exponents with decimals. We till now we dealt with exponents without any decimals. So we were talking about, even when I gave you question, those were about integers, or not even integers. I gave you all natural numbers. But now, to deal with decimals, all we have to remember is how to multiply and divide by decimals, because power is nothing but repeated multiplication or repeated division. For example, 0.2 square was 0.2 into 0.2. What would it be? 0.04. That we did yesterday. We need two decimal places. We multiply 2 and 2, and after this decimal point we need two numbers, two digits. This is how. So I can write, in other words, 0.04 raised to 1 by 2 is equal to, if square of 0.2 is this, square root of this is 0.2, or in more general sense, plus minus 0.2, right? Similarly, what is 1.3 into 1.3 or 1.3 square? 1.69. So 1.69 raised to 1 by 2 is plus minus 1.3, right? Similarly, we can do for cube. Here we take square. What would be there for cube? 0.2 into 0.2 into 0.2. It would be 0.008. Three decimals would be there. 0.2 into 0.2 into 0.2. What would be 1.2 क्यूब? 12 का क्यूब कितना होता है? कल देखा था. क्यूब क्यूब ये तो हार्डी रामानुजन नंबर में भी देखा था. This cube was there. What would be? Decimal point would be 3 places here, because we are multiplying 1.2 into 1.2 into 1.2. There are 3 on the left hand side, so 3 would be on the right hand side. Okay. So this is how you multiply, take powers of decimals. We are taking simple examples. You can take complex as well, little bit. 0.02 क्यूब क्या होगा? क्या होगा? Here there are 6 digits after decimal point, 2 for each. Nothing but 0.02 into 0.02 into 0.02. We multiply directly, we get 8. And how many decimal points we need? 6. So, okay, yes. And इसका क्यूब रूट क्या होगा? वो होगा. Cube root of this particular number would be 0.02. Yes. And all other things you can always do, like 1 upon 0.04 raised to 2, or 0.04 raised to minus 2 is equal to this particular thing. It would be 1 upon 0.0016 equivalent to, you get rid of decimal places, divided by 16, okay, and so on. And you can play around with all these rules. You can get the answer. Now, do few questions. फर्स्ट का बताओ क्या होगा आंसर. दिस इज नथिंग बट 1 upon 1.69 रेस टू 1 by 2, राइट. माइनस होगा तो वो डिनोमिनेटर में चला जाता है चीज. 1 upon a raised to minus n is 1 by a raised to n वाला चीज, राइट. दिस इज नथिंग बट 1 by plus minus 1.3. We'll leave it at that. We don't need any further answer. This is okay. Right? What is this? 27 का स्क्वायर है. This plus minus 2.7. What is this? 0.9. प्लस माइनस लिखना चाहिए मुझे. नो, बिकॉज इफ आई राइट माइनस -0.9 इंटू -0.9 इंटू -0.9 क्या होगा? -0.729 होगा. माइनस इंटू माइनस 3 टाइम्स negative sign would come. So is cube root of this particular number is only positive. Other roots would be not real. Okay. Hmm? Achha. That is right. My point is you cannot do directly like this because 0.9 into, so whenever there is one decimal point, if you cube it, there will be three decimal points in the right hand side. If there are two decimal points in the left hand side, when you cube it, there will be 6 decimal points on the right hand side. So if there are decimal points which are not divisible by 3, like this is 2 decimal points, you can't find cube root directly like this because this is neither 0.9, this is neither 0.09 or any of the such powers. Cube root of this particular number would be some very ugly number, ugly as in not very simple. What you did was correct. At the most you can do is you can clear the base, you can write it at this raised to 1 by 3, which you can write it as 9 by cube root of 100. It is fine, but beyond this you can't do anything. That is why I have purposefully asked this to tell you that if there are 1, 2, 3, 1, 2, 4, 5, etc. Decimal points after digits after decimal points, then you cannot directly take a cube root as if they don't exist. If there are 3 or 6, you can just directly take the cube root as if they don't exist and then adjust for the decimal point. That you can do. And what would be this? Can you do something? What is this? 1331 is cube of 11. But is that useful? हाँ, 1.1 cube होगा वो? नहीं होगा ना, 3 decimal points आएंगे. 1.1 cube, there would be 3 decimal places, right? 1.1 cube would be 1.331, not 13.31. There would be 3 decimal points because it is 1 here, so 1 plus 1 plus 1, there would be 3 on the right hand side. Are you following? It will take time. You can disrupt me, it's not an issue. You can stop me anytime. You can ask me to go through. What we are talking is whenever you cube any number having decimal point, let's say 1.1 cube. What is it? 1.1 into 1.1 into 1.1. Right? This is just what cube looks like. So how do we multiply these numbers? We just multiply as if there is no decimal point and then adjust for. So multiplication is 1331. So where should I put my decimal point? After 3 numbers, right? So this is not that number. This is 13 point something. If I do this 0.11 cube, it would be 0.11 into 0.11 into 0.11. Now I multiply as if there is no decimal point. Now where should I put the decimal point? After 6, these are 4. So 5 and 6. It's not that number as well. So there are 2, here is 1. So if I directly multiply, it is 1331. So this particular number is not cube of 11, 1.1 or 1.0.11, etc. Everywhere you will have number of digits after decimal point divisible by 3, right? Because here we are adding 1 plus 1 plus 1, here 2 plus 2 plus 2, here 0 plus 0 plus 0. Similarly, for next step, we will add 3 plus 3 plus 3. So everywhere we will get numbers divisible by 3. Here only 2 digits after decimal place, it won't be divisible by 3. इसका क्यूब रूट जो है ना वो ऐसा नहीं दिखेगा. Cube root of that particular number would look entirely different. You can find it on calculator, not otherwise. So it's not important, but if the question comes and options are similar looking, then it is important. At the most you can do is what he did, clear the base. You can write it as 1331 divided by 100 raised to 1 by 3, and then cube root of this numerator is 11, cube root of denominator is just right like that. You can do at the most. Fine. Okay. Next question, what would be this? It is 1 upon 1.728 raised to 1 by 3, which is 1 upon, what is cube root of 1.728? 12. You have to adjust for decimal point as well. Is it 1.2? 1.2 into 1.2 into 1.2 is equal to 12 का cube है 1728, 1 plus 1 plus 1, this number. Cube root of this particular number is 1.2. This is the answer. So we are taking cube root irrespective of the decimal point. 1.728 क्या है? 1728 है. If we ignore the decimal point, the number is 1728. What is the cube root of this particular number? It is 12. It is 12. Now we look for where is decimal point. It is after 3 digits. So since we are talking about cubes and cube roots, if there are 3 in the right hand side, there will be 1 in the left hand side. Because in the left hand side, 1 plus 1 plus 1, it becomes 3 on the right hand side. If there were 6 on the right hand side, there would be 2 plus 2 plus 2. If there are 9, 3 plus 3 plus 3. And only when these are divisible by 3 number of digits following decimal place, then only we can have nice cube roots like this. Otherwise, you find numbers like this. Here there are 3 digits after decimal place, so we can take cube root very peacefully and we get nice number. Next question. Now here there are 2 numbers, but base is not same. Base is different. So what is 0.2 cube? Zero 0.2 cube into 1 upon 0.064 raised to 1 by 3, right? Is nothing but 0.2 cube into 1 upon, what is this? Cube root of 64, 4, and there are 3 in the cube. So in the cube root, you will have 1, right? Is same as 0.2 cube is 0.008 divided by 0.4. Now you can just multiply by 1000 or directly divide if you are comfortable. क्या होगा division? 8 divided by 4 is 2, and decimal point would come here 3, here 1. 3 minus 1 is 2. Come here. Or you can multiply by 1000 to the numerator and denominator, and then come to that answer. No issue. ठीक है? I don't think you are 100% comfortable yet with all these things. It will take some practice. Do you want some problems for home assignments? 4 or 5 problems. How to deal with power in decimals. ठीक है, कर लो भाई, ट्राई करना, हो जाना चाहिए अभी. 2 मैंने मिस आउट कर दिया क्या बीच अरे I can क्या है 1.728 raised to minus 1 by 3, right? Is equal to clearing the base 1728 divided by 1000 raised to minus 1 by 3, right? Which is 1728 raised to minus 1 by 3 divided by 1000 raised to minus 1 by 3, which is 1000 raised to 1 by 3 divided by 1728 raised to 1 by 3. Minus becomes flip, minus flips. What is cube root of 1000? 10. Cube root of 1728. That was the answer. Or if you want, this was the answer. We got divided by 10, both numerator and denominator. Right? Cube root of 1000 is 10. This particular thing. Question number 8. Question number 8 है 0.7 to the power minus 2 into 0.49 to the power of minus 1 by 2. Okay, fine. This is, let's just keep it like that. What is this? 0.49 to the power 1 by 2, right? This is 0.7 raised to minus 2 into 1 upon, what is this? 0.7. Now this is directly, base is same. 0.7 raised to minus 2 minus 1. This is division, na? Reverse of multiplication. I can write this as 0.7 to the power minus 2 divided by 0.7. So this is 0.7 raised to minus. We'll keep it at that. Or you can actually write this as 0.7 cube. This is same as 1 by 0. क्या होगा 0.7 का cube? 0.343. That would be the answer. Observation is, here I observed that square root of this particular number would be 0.7 and then I'll get same base. So that's why I didn't square it right away. Or I could have squared it and then dealt with 0.49, then also I could have gotten same base. Then I would have to do fraction addition and subtraction. Instead of that, I chose to do in the integers because we have not yet studied fraction addition. Then the next important thing is units place of exponents, units digit. Many times these questions get asked, what was the units place of this particular number, or what would be remainder when we divide particular number by 10. It is nothing but finding unit place. So finding units place is very frequently asked question, and all it will use is how do we multiply numbers. For example, what would be units place in this particular number? I am talking, I need only units place, no other place. I am not worried about anything else. 5. How did you know? We know that square of 25 is 625. So 5. But what about 125 square? It will still be 5 because in the multiplication, let us say 125 into 125. First step would be multiplying 125, 5 into 125 we do. So it will be 5 into 5, 5 would come here and then some numbers would come. In the next step, we write 0 here, then multiply by 2. Then we write 2 zeros here, then multiply by 1. So it doesn't matter how many digits are here. It will always be some number of zeros, and then what would be units place? Always 5. right? It doesn't matter the number. So I ask you 125 or this square will always be 5 units place. Rest of the things are different. But what about still 5? Because units place will just get multiplied that many times. 5 into 5 into 5. It will always be 5. 5 into 5 is 25. 25 into 5 is 625. Into 5 still at the end it will be 5. So if there is at the units place, if there is 5, you take any power, units place will always be 5. Similarly, if you take any power of 10 or 20 or 30, units place क्या होगा? हमेशा 0 होगा, because that is how we know multiply number. So let's say 60 into 60 into 60, however many times. We multiply 60 into 60, 0 into 0, units place. Next 60 comes, still 0 into 0. Next 60 comes, still 0 into 0, units place. So it doesn't matter how many times you multiply, units place will always be 0. In fact, raised to 1, 2, 3, 4, 5 into 10. Units place क्या होगा इसका? Even if 10 comes exactly once, then even then you will have units place as 0. Why? Because this number then becomes divisible by 10, and if number is divisible by 10, you need 1 0 at the end. Question, we saw that question that we were trying to find remainder when that particular number was divided by 10. It was same as finding units place. If the units place is 0, number will be divisible by 10. Right? Anyway, that was. But what if we don't have 5 at the end? Something like 2. 2 raised to 120. 2 raised to 120. I want to find units place of 2. 2 raised to 120. Now let us write first few powers of 2. 2 raised to 1 क्या है? Units place. You just tell me units. 2. 2 raised to 2. 4. 2 raised to 3. 8. 2 raised to 4. 6. 16. 16 का 6 आता है. 2 raised to 5. 32 होता है. 16 into 2. 32. So 2. 2 raised to 6 is 64. 2 raised to 7 is 128. 2 raised to 8 is 256. Do we see pattern? 2468, 2468. Okay, 2486. Why is this happening? See, first you get 2. Then you multiply it by 2. Next power, one more 2 comes. 2 into 2, 4 आता है. Next power comes. 2 into units place पे multiplication कैसे होता है? 2 into 4 होगा. 8 आता है. Then one more 2 comes. Units place पे multiply करेगा. It tries to multiply at units place. 2 into 8, 16. So 6. Then one more 2 comes. It will get multiplied with this 6. 6 into 2, 12. Again we get 2. Again same pattern repeat. One more 2 comes. 2 into 2, 4 आता है. One more 2 comes. 2 into 4, 6, 8 आता है. Etc. Only units place. We are tracking only units place. Everything else is immaterial for now. We just want what is the units place. So units place for any power of 2 comes in this brackets of 4. 4 4 के bracket में repeat होती है चीज. Okay. Now, when I want to find power of any number, what I want, where does this power, that is 120, figure in these brackets of 4? If 120 comes here, n digit would be 2. If 120 comes here, n digit would be 4. If it comes here, it would be 8. If it comes here, it would be 6 in the brackets of 4. Like 246, 2486, 2486, 2486, 2486, 2486, etc. So where does 120 figure in those all these things? So can you see that if we divide that particular number by 4, and whatever is the remainder, that is where it will figure. So for example, let's leave 120 aside. Let us take some smaller number. Let me just write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. First 20 numbers. First 4, ये block है. This block is first 4 numbers. So for these powers, these are unit places. For next 4 numbers, these blocks, these are unit places in this order. So for 2 raised to 8, unit place would be last 6. For 2 raised to 6, it would be 4. Then next block 9, 10, 11, 12. For 2 raised to 9, unit place would be 2, 2, 4, 6, 8 है ना, 2, 4, 8, 6. So unit place will be 2 for this, 4 for this, 8 for this, and 6 for this. Again next block 2 for this, 4 for this, 8 for this, 6 for this, 2 for this, sorry, 2 for this, 4 for this, 8 for this, 6 for this. When number is divisible by 4, it is always 6, because everything is coming in the blocks of 4. If the number is divisible by 4, like 8, 4, 12, 16, 20, you have 6. When the number is 4k plus 1 type, so number divisible by 4 plus 1, 17. Here 1, 5, 9, 13, 17. These are this type of numbers. 4 into something plus 1. In other words, these are the numbers which when we divide by 4, give us remainder 1. These are such numbers 9, 5, 1, 13. So when we divide that number by 4, we have 1 remainder. There we have 2, 2, 2, 2. Here we 2. When we have these numbers which are giving remainder 2, when we divide by 4, 6, 10, 14, 18. What is unit place? 6. No, 4, 4. 2, then 4, remainder 1, remainder 2, remainder 3, remainder 0. 4 is equivalent to 0. That is what we need. We need what is the remainder when we divide that power by 4. Now can you see that remainder is 0? $120 is clearly divisible by 4. You can try to divide. 30 into 4 is 120. So remainder is 0. What would be unit place? 6. Clear? Tell me unit place of all these numbers. Yes, that is what the rule is. Rule is when we want to find units place of any power of 2, numbers or the last digits get repeated in the brackets of 4. So we divide whatever the power is by 4 and we find out remainder. If the remainder is 1, If the remainder is 1, units place is 2. If the remainder is 2, units place is 4. If the remainder is 3, units place is 8. If the remainder is 0, units place is 6. Why is that happening? Because powers of 2 keep repeating in that brackets of 4. That is how we define power. What is unit place here? 2, no? Remainder is 1, so power is 2. 52 is divisible by 4, plus 1. What is this? 8. This is 120 plus 3. Here 4. Remainder is 2. Here again 4. Remainder is 2. We have not studied divisibility test of 4, but let me tell you divisibility test of 4. Divisibility test is basically how we decide if that particular number is divisible by 4. So irrespective of whatever numbers are there, when we want to check if that number is divisible by 12, for example this, we just check last 2 digits. If last 2 digits are divisible by 4, we say that number is divisible by 4. Only last 2. This is the test of divisibility of by divisibility of 4. If this last 2 digits are divisible by 4, then the number is divisible by 4. We'll do that. Next section is I guess that only. Anyway, that would be helpful here. So last 2 digits are 90. This is not divisible by 4, but 88 is divisible by 4. 88 plus 2 is 90. So remainder is 2. So last digit is 4. Again 30. 30 is not divisible by 4. 28 is divisible by 4. Again remainder is 2. 24. 24 is divisible by 4. The remainder is 0. Last digit is 6. Now this particular thing. This is not 2. This is 122. Base is not 2 now. Would it make any difference? It doesn't make any difference. When we are talking about units place, only units place matters. Only unit place matters. Only units place matters. Because, for example, let's say 1, 2, 3, 2 into 1, 2, 3, 2. If we try to multiply directly, we multiply units place with unit place. We do this by 4, then whatever follows, and then we write 0, then whatever follows, we do this 0, 0. When we add unit place, only this multiplication was relevant, units place into units place. That is why it doesn't matter what number you take as a base. If only this particular units place is what is relevant for us to find units place of this particular power. Okay Vivek, I'll repeat. हाँ तो इसका बता दो, what would be units place here? 6 कैसे है? 52. अच्छा, okay 6. Remainder is 0. 52 is divisible by 4. Here again 6. 40 is divisible by 4. Here 2, because this is 21. 20 is divisible by 4 plus 1 remainder. So we have 2 as a units place. Okay, let me repeat it from the starting. What were we trying to find out? We were trying to find out units place of power. We are only concerned about units place because that is how questions are getting asked. What is unit place of this particular thing? Similarly, we can extend similar principles to last 2 places. That question has also been asked once, not more than that. Question was, what is the remainder when we divide that given number by 100? So remainder when we divide by 100 was last 2 digits. Remainder when we divide by 10 is last 1 digit. So if you are given such kind of question that what is remainder when, let us say, 0.12 raised to 234 is divided by 10. If this is the question and there are 4 options, these are 4 options, you want to deal with this kind of question. That was our entire purpose of studying this section. So we were saying that when we are trying to find out units place, all that matters is what is at the units place in the base and where does this power figure out in the brackets of 4. What is the remainder when we divide this particular power by 4. Why was this happening? This was happening because when we try to take powers of 2, powers of 2 raised to 1, 2 raised to 2, 2 raised to 3, etc. What digits appear at units place repeat in the pattern of 2, 4, 8, 6, then again 2 raised to 5, 6, again here 2, 4, 8, 6 and so on. This pattern keeps on repeating when we are trying to take powers of 2. Why was this happening? Because in multiplication, units place gets multiplied with units place and rest of the things are immaterial to us, and we are only trying to find out units place. That was why this pattern was repeating. So 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16, 16 into 2 is 32, 32 into 2 is 64 and so on. This was happening. So this pattern kept on repeating. So accordingly, what we said was, okay, so this pattern is repeating in the brackets of 4. So whenever I want to take any power of 2, all I need is where does this particular power figure out in this pattern. If I keep taking it, that pattern to all the numbers, where does this number figure out? We saw that when we divide this number by 4, the remainder that was coming up, that decided where does this number figure out. So if the remainder is 1, if the remainder is 1, units place was 2. If the remainder is 2, units place was 4. If the remainder is 3, units place was 8. If the remainder is 0, units place was 6. And that was the rule. And further, we saw that it's okay if we get 2, but even if in the base there are other numbers which are not relevant, but units place is 2, then also the same thing applies. All I need to check is whether units place is 2 of base, and then where does this power figure out in the brackets of 4, or in other words, remainder when we divide this number by 4 is 1, 2, 3 or 0. That was all that was needed. And for that I told you divisibility test of 4, which we are anyway going to study in the next section. When we divide this number by 4, whatever the remainder, here 42 is divisible by 4, the remainder is 0, so unit place would be 6. In this particular question, see, the base has 2 as the units place, so you can use that particular test. And 234, where does this appear? 232 is divisible by 4. Why 32 is divisible by 4? The remainder is 2, unit place would be 4. Sorry. What is remainder when we divide anything by 4, anything by 10? No, remainder, any natural number, let's say 11, 12, 13, we divide these numbers by 10. So there is division is, here is this 11, 12, 13, here is 10, divisor, and this particular thing, remainder. What is this remainder? Units place. Because how does 10 go? 10 go in the brackets of 10, 20, 30, etc. Somewhere there will be 330, 340, somewhere there will be 1230, etc. This is how 10 goes, like when we multiply, keep multiplying it. So what would be the remainder? of any number when we divide by 10, it would be this particular number plus the unit place. If I want to divide, let's say 1, 2, 3, 4 divided by 10, I go till 1, 2, 3, 0 and plus 4. So whatever is there in the units place, that is what remainder is. So that is the question. Question is remainder when divided by 10, it is equivalent to finding out units place. And units place we know is 4. Okay. It would be difficult. It would not be this simple. Hmm. Hmm. No need to memorize. Question would be asked either for 2 or for 3 or for 5 or for 10. They won't ask for they won't ask for other numbers. That is for sure. So this pattern we saw for 2. Tell me first few powers of 3. Units place. Only units place. Tell me units place. 81. So you don't need to memorize this. Just write first 4 powers. So this is the pattern. You'll understand. No need to memorize. Again, powers of 3 come in the bracket of 4. Exactly same. Nothing changes. Nothing changes. So what would be unit place here? Unit place. These are first few powers of 3. They also repeat in the brackets of 4. Remainder is 1. So 3. What would be remainder here? Base पे 3 है, वही important है. Rest of the things don't matter. Remainder would be 3. You don't have booklet, na? Can you get it from the office on third floor? 4 से pattern is following 4 वाला ना. 2 का भी case में भी we were dividing by 4 only. Here also we will divide by 4 because units place is repeating in the brackets of 4, not in the brackets of 3. We will divide by 4, find out the remainder. Here also we will divide by 4, find out the remainder. What is remainder? 3. 120 is divisible by 4. So remainder is 3. Units place would be 7. Online students, are you guys following? Am I going too fast? तुम्हारे बुकलेट में लास्ट जो क्वेश्चन है ना, व्हाट इज यूनिट्स डिजिट इन वो प्रोडक्ट, वो वाला देखो, वो समझ जाएगा. चलो इसके बाद प्राइम नंबर्स चालू हो रहा है. स्टोरी बताऊंगा अच्छी. प्राइम नंबर इज वेरी इंटरेस्टिंग. एक्सपोनेंट्स वाले सेक्शन में जो यूनिट्स डिजिट इन एक्सपोनेंट है ना, वो अलग, उसको मैं लिख ही लेता हूँ, मुझे लिखना तो है। क्या है यूनिट्स प्लेस? 0 आना चाहिए. What is units place for this? 1 remainder is 1, so it would be 3. Here remainder is 3, so remainder is, doesn't matter, it would be always 5. Here remainder is 2, so you have 4. And what did we say in multiplication? Units place only gets multiplied with itself. When you multiply these three numbers, whatever they come, and you try to multiply them, firstly these two numbers, unit place into units place, will get multiplied. Something will come here, then this number will get multiplied with this units place, so only unit place will get multiplied. Anyway, what is this? Unit place of this product is 0, so this number is divisible by 10. In other words, question वैसे पूछेगा कि is this number divisible by 10 or not, something like that. So yes, indeed it is. Right? No concept is required here except multiplication. All we are doing is multiplying repeatedly. Power is nothing but repeated multiplication, and since we know when we multiply two numbers, units place gets multiplied with units place and it stays there. Rest of the places don't matter when it comes to units place. That is the only thing we are using here. That is why remainder is 0. This is clear, na? This can be the most advanced thing they can ask. They can't go beyond this. Okay, so mathematical operations clear till now, whatever we are doing. Can you tell me your names? मुझे नाम ही पता नहीं है तुम लोग के. हाँ, ओमेंद्र, प्रभाकरन, स्वप्निल, कुणाल, प्रकाश, शाहरुख. दो तीन और बार बताना पड़ेगा तुम्हें, मुझे याद नहीं रहेगा एक बार में. Okay, so online students, should we move ahead? Prime numbers पढ़े थोड़ा सा. Prime numbers, there are two kinds of numbers in our number system. We are strictly talking now for natural numbers. We are not going beyond natural numbers. Okay, natural numbers means 1, 2, 3, 4, etc. Way we count naturally. Discrete objects we count naturally. That is how. That is where we'll see. Okay, last question repeat करना. See, these are things we studied already. When units place is 3, units place of some power whose base is ending with 3, whose base is ending with 5, whose base is ending with 2. That is the same thing. We calculate that independently. So here base has 3 at the end, and power, remainder of power when we divide by 4 is 1. So units place of this particular number is 3. Similarly, 5 raised to anything, units place will always be 5. And here base is 2, remainder when 20 we divide 22 by 4 is 2, so units place would be 4. So these particular numbers, you can call them ABC, they have at units place 3, 5 and 4. So when we multiply those three numbers, units places get multiplied with units places. Rest of the things don't matter when we want to only find units place. We are not concerned about other things. So let us say these numbers are, let's say A, B, C, D something. At the end you will have 3. These are D, E, F something. At the end you have 5. You multiply these two numbers, what would be units place? 5 into 3, 15. There will be some carry forward and so on. And when we try to multiply other things, everywhere else, you get 0, 0, 0, multiple zeros, and you add those things. That is how we multiply two numbers, two big numbers. 5 is multiplied by all these numbers. That is written here. Then you try at 1, 0. Then this place, this second digit, second last digit is multiplied by all these numbers. You write that in the second line and so on. You add all these things. Basically, in the units place, you will still get 5, which is nothing but 5 into 3 wala 5. Whatever this product is, that let's say x, y, z, something, something, at the end 5. That is multiplied by some, what can I say, a1, b1, dot, 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 4. If you want to multiply these two numbers, we multiply 4 into 5, comes 0 here, and something, something. When we try to multiply by tens place to this number, we first add 0, then we multiply. We add 2 zeros here, then multiply. So we keep adding it. At the end, we will get 0, which was nothing but units place of whatever we multiplied this number. That's the thing we get. Because in multiplication, only units place are coming into picture when we are trying to find out units place of product. That is, fine. We are talking about natural numbers when we are talking about prime numbers. We are not going beyond domain of natural numbers. So prime numbers are those numbers which have only itself and 1 as a factor. That is the definition. There are only two factors, 1 and itself. That is your prime. For example, if you consider for any number, 1 is always a factor. That is trivially true, because when you try to divide anything by 1, you can simply write it as 1, 2, 3 minus 1, 2, 3 and remainder is 0. So 1 is always factor. We are talking about natural numbers, so all the jumps are in terms of 1. So 1 will always be a factor. 1 is factor of all the numbers, that is given. And the number itself is always a factor of itself. For example, here you can write 1, 2, 3. 1, 2, 3, 1s are 1, 2, 3 and remainder is 0. Number itself is always a factor of number. 2 is always a factor of 2, 3 is always a factor of 3, 4 is always a factor of 4 and so on. Remainder will always be 0 when you divide 4 by 4. In the tables as well we do, na? 4 1s are 4, 5 1s are 5, 7 1s are 7, etc. So number and itself are always factor of any given number, any given natural number. Prime numbers are those who have no other factors. Only factors are 1 and itself. For example, 3. What are the factors of 3? 1, yes, and 2 is factor of 3? No. 2 के table में नहीं आता ना 3. And remainder is 1, remainder is not 0. Factor is remainder 0 and 3. So 3 is a prime number. What about 6? 1 is a factor? Yes. Is 2 a factor? Yes. 2 into 3 is 6. 3 is also a factor. Then 5 no. 6 is also a factor. So there are other factors than 1 and itself. So 6 is not a prime number. Is 2 a prime number? Factors are 1 and 2. Only 2 numbers are smaller than it. So we only need to check for this. So 2 is also a prime number. Can any other even number be prime number? For example, 4, 6, 112, 120. Can these be prime numbers? No. 2 will always be factor of these numbers. 2 will always be factor of these numbers. So any other even number cannot be prime number. 2 is the only even prime number. All other prime numbers are odd. Is 1 a prime number? Yes? No? 1 is not a prime number. 1 is neither prime number, not a composite number. Remember this as a fact. 1 is not a prime number, neither a composite number. So what is smallest prime number? 2. Smallest prime number is 2. 1 is not a prime number. Fine. Is 15 a prime number? 3 is a factor. 12 cannot be prime number. 17 is a prime number. Then 27, no. 79, yes. 85, can anything which has 5 at the end be prime number? 5 will always be factor of that particular number. Can 50, 70, 80, 90, etc. Can they be prime numbers? Never. Okay. So basically, whatever prime numbers we are having, multiples of that cannot be prime. The study of prime numbers is very old, because all the ancient civilizations, they knew about mathematics. They have studied mathematics in quite some depth. So prime numbers have always enthused mathematicians across civilization. We have seen this. And there was this mathematician Eratosthenes. He was around the time of Pythagoras. He was trying to find out how to determine if how to test if particular number is prime or not. How to test if particular number is prime or not, or how to find out prime numbers till some particular number. Let's say I want to find out prime numbers till 100. How do I do that? So he conjectured or found out some method. He called it his sieve. Sieve पता है? छन्नी. Sieve. 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 Eratosthenes का sieve बोलते हैं उसको. What he said that if I want to find out all the prime numbers till some particular number n, let's say 100. So I find out prime number till square root of 10, square root of n or square root of 100. It is 10. What are the prime numbers till 10? 2, 3, 5, 7. This is very easy, finding out first prime numbers till 10. And then I take all the multiples of 2, 3, 5, 7 out of the picture till 100. So I take all the multiples of 2 out, all the multiples of 3 out. They go out of the sieve. All the multiples of 5, all the multiples of 7, I take out. Whatever remains are prime numbers till that particular number. So if we know prime numbers till 10, we can find out prime numbers till 100. If we know prime numbers till 100, we can find out prime numbers till 10,000. This was very ingenious. It was around 200, 300 BC. So it was very ingenious and was used by him very effectively. Now, of course, we have algorithms to find out. We have supercomputers finding out primes and all. But this was the test he used to find out numbers till some particular given n. And this problem of finding out prime numbers or testing if particular number is prime or not has become incredibly crucial, because prime numbers, as I said, are at the foundation of what we do today. There is something known as RSA cryptography. RSA, public key cryptography. Whatever transaction we are doing digitally or anywhere we are keeping our data secure, there this cryptography is at the heart of it. It is based on prime numbers. We find out huge prime numbers, we take their multiplication, and these are keys to that particular combination or lock or security. One is public key, which is known to everyone. One is private key, which is only known to you or the user. And when they combine, then only you can crack the code or crack the security. That is the thing. So huge prime numbers are always interesting, and scientists, mathematicians, computer scientists, they are always finding out bigger and bigger prime numbers, because the bigger the prime number, securer the data. transaction more and more secure हो जाते हैं. And why does this work? Because whatever algorithms we have today, they cannot find out if the particular number is prime or not in sufficient amount of time, even using supercomputers. Even supercomputers take thousands of years to test if that particular number is prime or not. That is why they work. Otherwise, they won't work. For example, if the quantum computer comes and they crack our code, RSA cryptographic keys within seconds or minutes or hours, then everything we know, we have to throw it out. Abhi, last year, you might have read that Google claimed supercomputing, quantum computing ability. They have this quantum computer called, anybody remember? Sycamore. This Google's quantum computer. It is, I guess, 53 qubit or something like that. But yeah, they claim that there was a algorithm which needed to generate some sequence of numbers according to that algorithm. It would have taken best supercomputer we have 10,000 years to solve. But this particular thing solved it within 200 seconds. Basically, if that becomes the norm, everything we know would be irrelevant. But as of now, it is still a claim, and quantum computer at least are not as common as they should be or they would be in the future. China has taken high leaps in this area of quantum computing, so we also should be worried about it. And to counter that, there are new cryptography like quantum cryptography is coming up. That is also area is now being studied. Anyway, coming back to prime numbers, this was the few method of Eratosthenes. Then, of course, one more story I'll tell you about prime numbers or how to test prime numbers, and it has other consequences which you can use anywhere. I mean, in your essays, in your answers, in your interview as well, to justify your other point. Story was like, what we want to test if particular number is prime or not. It is called primality. Primality testing. We want to find out if particular number is prime or not. There is no one way to do that. There is no definitive way to do that. But in 2003, three computer scientists at IIT Kanpur developed an algorithm to do that. It is called as AKS primality test. Of course, we are not concerned about what the test is because it could be very complex or something. A is Agarwal, Kayal, Saxena. These are the names. Professor Agarwal was professor at IIT Kanpur, and these two were his students. And this particular test came out of undergraduate research project. This test come out, and this is the way to tell if particular number is prime or not in definitive way, without making assumptions, no assumptions, and with reasonable time. This particular result is considered as one of the foremost results of 21st century. This happened in 2003. So the point is, firstly, if somebody tells you that Indians are not doing good in mathematics now, they were doing it earlier, that is not true. We are doing great even now. Of course, there are problems which we need to address. Because in one of my interviews, interviewer posed me this question that why are Indians not doing as good as they should in India, but when they go out, they do extraordinarily well. So of course, you have to refute that claim. It is not true. We cannot paint everything in black and white. But yes, certainly there are problems which we can address, and you can then go ahead. So this is one test. Another point is why undergraduate research is so important. Because such extraordinary results can come out of undergraduate research. This was undergraduate project. Can you imagine? One of the most important results in 21st century came out of undergraduate project. So that is why research in education is important. That is again point you can make using this particular anecdote. Or in which way, if you want to use it, you can use it. I found it interesting. Anyway, coming back to prime number, yes. Another fact about prime numbers is there are infinitely many prime numbers, and proof of this was known to mathematicians for centuries and millennia. For example, in Euclid's book, most famous book, The Elements, he has given the proof. He says that if there are finite number of primes, let us say p1, p2, etc. up to some pn. These are assume किया कि finite number of primes है कुछ, and we'll show that this is not possible. This is proved by contradiction. So he says that then consider this particular number p1, p2 into pn plus 1. He says that if we know, if you say that there are only finite number of primes, as I tell you this particular number and this is also prime. This is bigger than last or the largest number and this is also prime. So your claim is not true, because this particular number would not be divisible by any number. So this is the prime. And simple proof is not required, but remember the fact that there are infinitely many prime numbers. We don't know how frequently they appear or any pattern in which they appear. Lot of research has gone into it, lot of pattern have emerged, but there is still no definitive way to find out which number is prime number, which is the next prime number. That is not what we can predict. If we could have predicted that, there would be no need for all those tests and all. Fine. Now we'll enlist prime numbers from 1 to 100, and that is something you should remember. 1 to 10, tell me which are prime numbers 1 to 10. 2, 3, 5, 7. 11 to 20. 11, 13, 17, 19. Then only check for odd numbers. Even numbers cannot be prime. That is given. Next, 31. Next, कितने हो गए? 25 हो गए? नहीं हुए, 25 हो गए? हाँ हो गए, 25. These are the first 25 prime numbers, or up to 100. These are the prime numbers. It's not very difficult to memorize them, because once you know first 8 prime numbers, you just have to check where there are very few in each bracket of 10. If you know the your tables well, you can easily find. Anyway, Aristophanes क्या बोला है? बस इनसे चेक करना है. If the number is not divisible by these numbers, then it is prime. Number which is not prime and number which is not 1 is composite. Composite number is number which is not prime and number which is not 1. Fine. टर्मिनोलॉजी पता होनी चाहिए बस. कंपोजिट नंबर क्वेश्चन पूछा गया है, इसी साल पूछा गया. इनफैक्ट वही क्वेश्चन है. देखो सीएससी 2020 का 2022 का क्वेश्चन देख लो. रीड द स्टेटमेंट्स. It says that two natural numbers are there, p and q. P is a prime and q is a composite number. Composite number is number which is not prime and which is not 1. हो रहा है, आंसर भी आ गया, क्यों एक क्यों नहीं है, मतलब फर्स्ट स्टेटमेंट, व्हाई इज फर्स्ट स्टेटमेंट रॉन्ग? First statement is P into Q can be an odd number. See, first and foremost, you should observe all the statements are can be. So it is high possibility that they are correct. Can be, may be, extreme कुछ statement है नहीं. This is prime, this is composite. Or when is product of two numbers odd? When both are odd, can we have odd prime number? Yes, there are many. Can we have odd composite number? Yes, 15, 9, there are so many. Definitely it is possible. और यू कैन जस्ट टेक एग्जाम्पल, कर लो, करके देख लो, 3 into 5, 3 into 9, कुछ भी करके देख लो. Q by P can be a prime number. Q is some composite number. So can we say that P square is a composite number? Do we know that P square is also a composite number? P is a factor which is not itself or 1. What is P square by P? P, which is a prime number. This is also possible, right? Can be है ना, can be तो कुछ भी हो सकता है. Or you can take few examples. 9 by 3 करके देख लो. 9 by 3 is 3. It is a prime number. Q by P is possible. Prime is possible. Third statement, P plus Q can be a prime number. So the statement is, this is statement number, this is statement number 2. It says that Q is some composite number and P is some prime number. So statement says Q by P can be a prime number. So I am taking any composite number. So P square is composite number. For any prime P, P square is also a composite number. So P square by P, which is what? P is a prime number. So yes, statement 2 can be true. And or if you don't want to deal with symbols, you can take some prime numbers. Example देके देख लो, जहाँ पे भी hit कर जाए, खत्म. For example, 9 by 3, 9 by 3 is 3, 3 is a prime number. Yes. Third statement, Q plus P or P plus Q is a prime. Is it possible? Q is a composite, P is a prime. 2 plus 3, नहीं, 2 plus 3, हाँ, 2 plus 9, 11 prime number है. No, no, no. Q is a composite number. Right. We just want one example. All the statements are can be. It's not always. Always वगैरह बोला होता तो वो गलत हो जाता. Right? Very easy question. What knowledge was required? Only you need to know what do we mean by prime numbers and composite numbers. No other extra knowledge was required. Basic arithmetic is very frequently getting asked, and you will require how much time? Like 30 seconds to solve this question, not more than that. Next question. Statements are given. First statement is n is a prime number. Second is n leaves remainder 1 when divided by 4. Question is, this is data sufficiency wala question, but just see that question is actually from prime number. Data sufficiency के format में पूछा गया है. Question का आंसर क्या करना है? If n is unique natural number between 10 and 20, what is n? N is some natural number between 10 and 20 that is given. We just have to find out n. N is between 10 and 20. That is given in the question. Can we find this out based on data given in statement 1? N is prime. How many primes are there here? 4, 11, 13, 17, 19. So we cannot find n uniquely here. There are 4 possibilities. So statement 1 alone is definitely not enough. Now statement 2 देखो, n leaves remainder 1 when divided by 4. Basically numbers of the type 4n plus 1 और some 4k plus 1 उसने यूज किया 4k plus 1. So 12 plus 1 13, 16 plus 1 17. Only two options are there, but two are there, no unique. So statement 2 alone is not sufficient to find out answer uniquely. But if you combine both the data, do we get unique answer? No. 13 and 17 are there in both the cases. So still there is no unique answer. The answer is D. Together not sufficient. Right? Understood? Online students, let me know. You can interrupt me. नेक्स्ट क्वेश्चन देखो. इफ ये हो गया तो नेक्स्ट देखो. ये समझ गया ना क्या किया? जस्ट जो भी स्टेटमेंट 1 से डेटा बाहर आ रहा था वो और स्टेटमेंट 2 से डेटा जो बाहर आ रहा था वो हमने प्लॉट किया अकॉर्डिंग टू द क्वेश्चन एंड वी वांटेड टू फाइंड आउट इफ यू कैन आंसर द क्वेश्चन. क्वेश्चन वाज व्हाट इज n, या फिर n इनमें से कुछ था. स्टेटमेंट 1 बोल रहा था, स्टेटमेंट 2 बोल रहा था इनमें से कुछ था. इंडिविजुअली तो नहीं पता चल रहा था, लेकिन कंबाइन करो तो भी पता नहीं चलता. दैट वाज ओके. This is in the data sufficiency type of question. We want to find out if we can answer the given question based on given data. The question is, we want to find out some number between 10 and 20, that question itself says, and we just want to find out that number. Now statement 1 says that it is a prime number. Now what are the prime numbers between this particular range? There are 4 options. So we cannot find out answer uniquely from statement 1 alone. And statement 2 alone से क्या मिल रहा था हमें कि numbers are of the type 4k plus 1, because remainder was 1 when we divide the number by 4. So there are only two such number between 10 and 20, 13 and 17. So here also we were not able to find out answer uniquely. But even if we combine the data, there is 13 and 17 were in the both places. So still we were not able to find out answer uniquely. So that's why it was not sufficient. Both the statement together were also not sufficient to answer the question. Question was, can we find n? Question number, next question देख लो, again data sufficiency. Question is P into Q odd? When is P into Q odd? When both are odd? When both odd? In data sufficiency questions, what we do is, whatever the question be, we ask ourselves, what is the information or data that I require to solve this question? So to answer this in terms of yes or no, what I need to know is if both these numbers or one of these numbers is odd or one of these numbers is even. Even if one of these numbers is even, this cannot be odd. So I answered the question. Answer could be affirmative or negative, that is not relevant. Answer could be no, this number is not odd, that is also an answer. But to answer that, I need to know if what is P and what is Q, is one of them odd, or are both of them odd, or is one of them even. If one of them is even, then also I have my answer. If no is, if both are odd, then also I have my answer. Answer is not important. Can I answer the question is important. Fine. Statement number 1 देख लो. P and Q both are prime numbers. Can we determine which are even, which are odd based on this information? Primes can be even. Yes, 2. We know that 2 is an even prime number. So based on this information, we cannot say that both are odd or one has to be even. That cannot be said. So this information is not sufficient to answer the question. We don't know if both are odd or one is even. We don't know. Statement 2, P plus Q is an odd integer. When is P plus Q odd? When one is even, one is odd? right? Definitely, in no other case is P plus Q odd. Even plus even होता है, odd plus odd भी odd होता है. That we saw. If this statement is true, then we have one even, one odd, definitely. So now can we answer this question based on statement 2? If there is one even number, one odd number, can PQ be odd? No. But we answered the question. Question is, we just want to answer the question. Answer could be affirmative or negative, that is not relevant. But can we answer the question based on this data? Yes, statement 2 alone is sufficient. Got it? Priyanka, did you get it? Prabhakar? Which one is odd, which one is even, we don't know. But one of them is odd, one of them is even. Because when is the addition of two odd number, addition of two integers or natural numbers, when is it odd? When one is odd, one is even. For example, even plus even is always even number. We saw that, huh? Like 2 plus 4 is always even, and odd plus odd is also even number. 3 plus 5. So what we know, if this is odd, then one of them is odd, one of them is even, definitely. And even if one of them is even, this would be even. Product of two numbers is even, even if one of them is even. So we answered the question. Is it odd? No, it is not odd. But we answered the question. Answer is negative. But we answered the question based on only this information. Clear? Firstly, we asked ourselves, what I need to answer this question. Is PQ odd or not? I need to know if both are odd or one of them is even. I need to know that information definitively. Any which information I get, that is sufficient for me. From first statement, I could not gather that information, because if P and Q both are prime, I cannot definitively say that one is even, another is odd, or both are odd. Both are possibilities, because there are odd prime numbers and there is even prime number as well. So I cannot conclude anything from first statement. But from second statement, I could definitively say that one is odd and one is even. Then only addition of two is odd. If it was even, then again I could not have concluded. There could be two possibilities. But if this is odd, I know that one is even and one is odd. It has to be like that. And because it is so, I can definitively say that this product is even. So this product is not odd. एकदम basic fact use किया है. Odd plus even is odd. Now no other concept is required. थोड़ा heavy लग रहा है? Heavy लग रहा है थोड़ा? Got it? Right. 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 हाँ. 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 3. Answer. हाँ. हाँ. Right. Right. Answer could be affirmative or negative. That is not relevant. You can answer the question. That is what data sufficiency is. $1 million कमाना है किसी को? $1 million, $1 million, around 8 crore rupees. I'll tell you a simple problem. If you solve that, you'll be awarded $1 million. There's something called as Goldbach conjecture. Problem statement is so simple that you will feel, हाँ ये तो बहुत simple. it says that for any number greater than 2, any even number greater than 2, we have two prime numbers such that n is equal to p plus q. For any number greater than 2, which is even, there are always two prime numbers such that that number is addition of two prime numbers. Don't write it down, it is not relevant for course. I am just telling you. $1,000,000 problem. There is this Clay Mathematical Institute which has given list of problems and they call it millennium problem. So if you solve that particular problem, you get $1,000,000 as award. This is one of those problems. This is one of the oldest problems in number theory. It seems so simple. I mean, you can also understand. And how much time I taught you prime numbers? 15-20 minutes. You can understand the problem. The problem is not difficult. You take any prime number. For example, let us take 8. You can write 8 as 3 plus 5. For any such even number greater than 2, you have two prime numbers such that there is addition. This is Goldbach conjecture. If you solve this, you get $1,000,000. There are other such problems as well. And one of those problems was solved in 2010. It was solved by this Russian mathematician known as Gregory Perelman. He is one of the most genius persons alive. उसने solve किया था. He solved that particular problem. It is called a Poincare conjecture. So he solved that, and Clay Mathematical Institute awarded him $1,000,000, and he said, "I don't need your money, you keep it." He was awarded Fields Medal, which is the highest award in mathematics. Fields Medal and Abel Prize. These are two highest awards. So this is relevant for GS as well. It can come as a statement. It is equivalent to Nobel Prize in mathematics. Because you don't get Nobel Prize in mathematics, there are various theories why you don't get Nobel Prize. Okay, you know one theory, na? Okay. So there is conspiracy theories are many. Why Nobel didn't give mathematics its due weight? So one of the conspiracy theories is because his wife ran away with a mathematician, something like that. So anyway, so the Fields Medal is equivalent to Nobel in mathematics. So he declined that as well. I don't want your medal. I don't do it for medals or money. So he stays in some basement in Russia in his mother's house. He doesn't get out, but he is the one of the geniuses that are alive. So since that time, no $1,000,000 question has been solved. If you solve it, good luck. Yeah. Huh? This is no prove करना है. Is it proof? Is it possible for all or not? Check नहीं करना है, prove करना है. We can check. There are supercomputers who have verified this for millions of numbers. But we need conclusive mathematical proof. Huh? हाँ हाँ थोड़ा बीच में हेवी हो गया इसलिए कुछ बताना पड़ा. लोग थोड़ा एकदम थके हुए लग रहे थे. हाँ prime numbers. Next is prime factorization. This is called as fundamental theorem of arithmetic. It says that any natural number can be written as product of primes or their powers of prime. So you give me any natural number, and either it is itself a prime number, or if it is a composite number, I can write it as product of prime numbers or powers of prime numbers. This is called as fundamental theorem of arithmetic. So any number, it can be written as some p1 raised to a, p2 raised to b, etc., pk raised to k, and so on. these P1, P2 are prime numbers and these are powers of prime numbers. Any number, any natural number can be written as is itself a prime, or if it is not a prime, then it can be written as product of powers of prime number. For example, 12 is not a prime number, it is a composite number. I can write it as 2 raised to 2 into 3, where 2 and 3 are prime numbers, right? If I take 60, 60 is not a prime number, so I can write 60 as 2 raised to 2 into 3 into 5. These are prime numbers. This is prime factorization of 60, this is prime factorization of 12, and so on. Now we want to acquire the skill to write any number into its prime factors. That is the skill that is relevant for us. We want to be able to factorize any number into its prime factors. Then lot of things become very easy, like finding LCM, HCF, like checking for divisibility. All those things become very easy once you can factorize number into its prime factors. So look at your booklet. I have given you two methods to do that. First is division method, another is factor tree method. The same question 36 will factorize using those two methods. For a factor tree method, what we do, we just factorize this and keep factorizing this until we get prime numbers. So for example, 36 is 4 into 9, 4 into 9, right? 36 is 4 into 9, 9 4s are 36. 4 is 2 into 2, 9 is 3 into 3. These are all prime numbers. So this is the prime factorization of 36, like 2 raised to 2, 3 raised to 2. For any number you can do this. You don't actually need to draw the tree. You can even do this in your mind. Mentally also kar sakte ho. It's not necessary that you every time draw this tree. This is just to explain how do you find out any factors you want and you reduce those factors till you get prime numbers. Somewhere down the line you will get prime number in one step or two step or three steps, not more than that. Other method is division method. Then you 36, you divide by prime number, smallest prime number you know that divides it, which is 2. Then it becomes 18. Till you divide by 2, it becomes 9. Then you divide by 3, it becomes 3. Then you divide by 3, it becomes 1. So that's where we stop. So this is prime factorization. 2 into 2 into this 2 square, 2 square, 6 square. Whatever method suits you, you can follow that. This or this. For bigger numbers, this could be longer. If you can do all those mental calculation, then this could be shorter. For bigger numbers. For smaller numbers, it is roughly same. Okay. Now, as a practice, let us try to factorize two numbers. Write prime factorization of all these numbers. कर पा रहे हो? कौन सा मेथड फॉलो कर रहे हो? 3 वाला? कोई भी कर लो, यही आंसर आना चाहिए। What is this? You can just separate the 10 out of it. You can write it as 36 into 10. 36 you already know. 36 is 4 into 9. So 2 square into 3 square, and 10 is 2 into 5, which is 2 cube into 2 cube 3, 5, right? Okay, 2 cube 3 square 5. Fine. This you can write it as 108 into 10. 108 is again 8 into 12, 9. 18 into 6. 18 into 6 is 18 into 6 into 10. So now you can do 2 here, here, here. So 2 cube, 3 cube into 5. Here 9 है ना? 18 is 2 into 9. 9 is 3 square. This is 1331 into 10, which is 2 into 5 into 11 cube. 1331 is 11 cube. 11 is a prime number, we know. Now ये कर लो. हाँ? 13. पूरा बता दो. ऑनलाइन स्टूडेंट्स तुम लोग कर रहे हो ना? बस देखो मत यार, करो भी. इट वोंट बी हेल्पफुल अदरवाइज. हाँ, हो रहा है 13 से. दोनों प्राइम नंबर्स हैं. और ये 162 into 100 इक्वल टू 162 क्या है? 81 into 2 है. 2 into 81 into ये है 4 into 25, which is 2 cube. ये है 3/4 5 square. ठीक है. हमने ट्राई किया. वी वांटेड टू फाइंड आउट प्राइम नंबर्स व्हिच डिवाइड दिस पर्टिकुलर नंबर. वी स्टार्टेड विद 2, देन 3 चेक किया, 5 चेक किया, 7 चेक किया, 9 चेक किया, 11 चेक किया, 13 चेक किया तो डिवाइड हो गया. चेक करना है इसको, वही करना पड़ता है. चेक तो वही करना है कि व्हाट प्राइम नंबर डिवाइड दिस, वही ऐसे इसको लिखते हैं 1261, यहाँ पे 13 लिखते हैं, फिर यहाँ पे 97 आता है, यहाँ पे 97 लिखते हैं, कुछ अलग नहीं है, वही करना, बट यहाँ तक जाना पड़ता है। अरिस्टोथेनिस क्या बोलता है, इफ वी वांटेड टू शो दैट दिस इज अ प्राइम नंबर, कहां तक जाना पड़ेगा, इसके रूट्स तक जाना पड़ेगा अप्रोक्सीमेटली। इसके पास कौन सा स्क्वायर नंबर है, कोई है, 30 का स्क्वायर 900 होता है, 40 का 1600 होता है, तो समवेयर बिटवीन 30 एंड 40 उतने प्राइम नंबर तक जाना पड़ेगा हमें। इफ यू वांट टू शो 40 तक अगर प्राइम नंबर हम लोग शो कर लिए, डिवाइड नहीं हो रहा, देन इट वुड बी ए प्राइम नंबर अकॉर्डिंग टू अरिस्टोथेनिस। तो बट वो नहीं पूछेंगे, दिस वाज आस्क्ड इन दिस ईयर्स CSE, you needed to factorize it. I am not giving you out of blue questions. This was asked in this year's CS. You can see the last question on the same page. है ना? So it is a product from 91 into 92 into 99 and you divided by 1261. And we want to find out remainder. Now we know this is 13 into 97. We divided by 13 into 97. 97 will get cancelled. Here it is, 97 is there, right? Now is there 13 here somewhere? 13 7 is 91. It is completely divisible. The remainder is 0. Factor है ना? So 1261 becomes factor of that particular product. The remainder is 0. अरे क्वेश्चन ही नहीं देता वो तुम्हें, कैसे देता? क्वेश्चन वुड हैव बीन सिमिलर, ज्यादा से ज्यादा क्या कर सकता था कि दिस प्रोडक्ट +2, अब रिमाइंडर निकालो, तो रिमाइंडर को इसको भूल जाओ 2 को, ये बता दो कि ये फैक्टर है, रिमाइंडर 2 हो जाएगा, ये कर लेता और क्या कर लेता। तो यू नीडेड टू नो दिस, प्राइम फैक्टराइजेशन अगर नहीं होता तो वो सॉल्व नहीं कर पाते। फाइन, नाउ वी वांट टू डिफाइन डिविजिबिलिटी इन टर्म्स ऑफ प्राइम फैक्टराइजेशन। जो भी हम लोग बोल रहे थे कि इफ द नंबर इज डिविजिबल बाय अनदर नंबर और इफ द नंबर इज फैक्टर ऑफ अनदर नंबर, दैट वी कैन डिफाइन और रीडिफाइन इन टर्म्स ऑफ प्राइम फैक्टराइजेशन। हमने क्या बोला है कि every number will have its prime factorization which will be unique. वो शायद यूनिक मैंने पहले नहीं बोला था, बट दैट प्राइम फैक्टराइजेशन वट एवर वी आर फाइंडिंग इट इज यूनिक, यूनिक अप टू ऑर्डर, मतलब 2 को 3 वो उनमें ऑर्डर चेंज कर सकते हो, वो कोई इशू नहीं है, मतलब इसको 13 into 97 की जगह 97 into 13 लिख सकते हो, दैट इज नॉट एन इशू, बट अप टू ऑर्डर दिस इज यूनिक। एवरी प्राइम फैक्टराइजेशन विच वी हैव फाउंड आउट इज यूनिक up to order for every number. That is what fundamental theorem of arithmetic is. Every number we can dismantle it and write it in terms of primes. For entire number system, prime numbers act as a building block. There are multiple blocks, there are multiple prime numbers, in fact infinitely many prime numbers. These are our building blocks for our entire number system. For any number we have its prime factor, and to talk about any number, it is always easier to talk in terms of its prime factors because prime factorization is unique for any number. वो बोल रहे हैं हम लोग। अब next thing we are talking about is for any number we have some prime, let us say we have some prime factorization, n is equal to some 2 raised to 3, 3 raised to 5, etc. This is some prime factorization of some number. Now this number is divisible by particular prime number. Let us say 2, only when 2 appears here. It is divisible by 3, only when 3 appears here. It is divisible by, let's say, 11, only when 11 appears in its prime factorization. Whatever primes appear in this prime factorization, those are the only prime factors this number will have. If I want to check divisibility by some other number, let us say m. M is something 2 into 7 into something. It's its prime factor. Is this n divisible by m? It will be divisible only when all the prime factors of m appear in this thing in some form or the other. So, for example, let us take one concrete example. A is equal to 2 cube 3 square into 7 and B is equal to 49. C is equal to 2 raised to 3 into 3. 49 is 1 square. Okay, we want to find out, is this particular number A divisible by B, or and is this number A divisible by C? In other words, are these two numbers factors of this number? Factors and divisibility we can use interchangeably. A is divisible by B means that B is a factor of A. Fine. Now, all we want is, for example, let us consider this C. Are all the prime factors with their corresponding powers appearing inside A? Does 2 raised to 3 appear inside A? Yes. Does 3 appear inside A? Yes. So this is factor of A. For B, does 7 raised to 2 appear inside A? No. 7 appears. So 7 raised to 2 is not there. 7 is only once. So this is not a factor. Or not a is not divisible by B. A is not a factor of, or B is not a factor of A. Clear? That is how we can redefine our concept of divisibility. So this particular number n would be divisible by m only when all the prime factors of m with corresponding powers appear inside n. Inside n means inside prime factorization of n. Because prime factorization is nothing but unique representation in terms of product of prime number. And divisibility and product, you know, they are the same operation. Division is nothing but inverse of multiplication. That is why everything can be happening. And because of this, you could solve this question very easily. To find out remainder, to claim that remainder is 0 was same as claiming that this 1261 is a factor of that particular number. When was it factor? When all the prime factors of 1261 were appearing inside whatever the prime factorization of this particular product may be. 97 तो पूरा cancel हो गया and 13 would appear in prime factorization because it is a factor of 91. We don't actually need to calculate prime factorization. We just needed to know that are these two appearing inside it. So they are definitely appearing. So it is a factor. The remainder is 0. Okay. The next वो पढ़ लो, note पढ़ लो, number of factors for any number, any prime factorization, p raised to a, q raised to b, r raised to c. Number of factors it will have is a plus 1, b plus 1, c plus 1. अभी के लिए just note it as a fact. You will be able to appreciate it fully when we will study permutation and combination. It is nothing but counting. There you will be able to fully appreciate it. मतलब ये obvious हो जाएगा तुम्हारे लिए. अभी के लिए just as a fact रख लो इसे. क्वेश्चन देख लो. नेक्स्ट CSE 2022 का 1 into 2 into what we want is what is the value of m. In other words, how many times 3 appears in this product. Just count करना है. प्राइम फैक्टराइजेशन में हम ऐसे ही करते थे, काउंट करते थे कितनी बार कोई भी प्राइम नंबर आ रहा है उसके अंदर, वही करना है. कितनी बार आ रहा है आएगा देखो. क्या हुआ, करो कैलकुलेट, काउंट कर लो बस. How many times 3 would appear in this product? ठीक. ये क्या है, प्रोडक्ट है ना ये, 1 into 2 into, I'll write it fully. This is the product. You want to find out, इसको ऐसे लिख सकते हैं. This is something like prime factorization. Prime factorization में we write it like this. This n could be again some prime factorization. So 3 raised to m into some other prime factors. We are not bothered about that. We only want to find out what is the power of 3 in the prime factorization. Basically, we want to count how many times 3 appears inside this product. It appears once here, 3 into 2 is 6, 9. It appears twice. 9 is 3 square. It appears twice here, then once here and once here. How many times it appears? 6. 5 seconds, 10 seconds. कितना लगेगा? This is this year's question only. 2022 paper. ठीक है, comfortable? Next question देखो. Let P be 2-digit number and Q be the number consisting of same digits written in reverse order. If PQ is equal to 2430, then what is the difference between P and Q? We are given product. P and Q are 2-digit numbers here. P and Q are not digits. P and Q are 2-digit numbers themselves. What we try to do, we try to split this number into 2 numbers, P and Q, such that they are reverse of each other. Did you get what I said? This is essentially product of 2 numbers. So we try to write this 2430 as product of 2 numbers, and we want to condition is those 2 numbers should be reverse of each other. This is little bit hit and trial. What you can say, 2430 is prime factorization क्या होगा इसका? 243 2430 है, कुछ और है नंबर? 2430 ही है ना? 243 is 3 raised to 5, 2 into 3 raised to 5 into 5, that is prime factorization, right? Let us write it in expanded form. Now I want to split this product into 2 parts such that one part is reverse of other, because that is the condition. Now थोड़ा सा ट्रायल एंड एरर करना है, दोनों भी 2-digit नंबर आने चाहिए. So let us try this and this. This 3 into 3 into 2, what is it? 18. What is this? 27 into 5, this is 3-digit number, so it is not allowed. Fine, so this is not the case. Let us take this and this. What is it? 9 into 2? No, 27 into 2, 54. This is आ गया? They are reverse of each other. Right? So bus, what is the question now? What is the difference between them? Difference is 9. नहीं, this is easiest and quickest. Other thing is, then you write it as, हाँ वो वाला चीज जो place value. You take P is equal to AB, Q is equal to BA, you write it as 10a plus b, you write it as 10b plus a, then you multiply, then you put another conditions that if LHS is divisible by 10, RHS has to be divisible by 10. If LHS is divisible by 3 raised to 5, RHS also has to. So these conditions you have to put. Is longer. It is definitive, but it is longer. हाँ नहीं क्यों छोड़ना है, ये देखो ना 3 स्टेप में आ गया. अब ये अज्यूम करके थोड़ी पेपर में जाओगे कि क्वेश्चन गलत होगा, ऐसे थोड़ी जाओगे. दिस इज इजी क्वेश्चन. ऐसा है कि आधे पेज का क्वेश्चन तो वो ठीक है, अगर थोड़े टाइम में नहीं होता है तो ऑफकोर्स इफ यू hit and try for 1 minute, 1.5 minute and you still can't do it, then move ahead please. बट ऐसा नहीं कि छोड़ दोगे, दिस इज नॉट छोड़ने वाला क्वेश्चन. थोड़ा सा खेलना है बस इधर उधर. मेंटल एबिलिटी क्या है, इफ यू आर गिवन अ प्रॉब्लम यू शुड बी एबल टू सॉल्व इट. रन अवे क्यों करना. ऐसे जरूरी नहीं है कि डेफिनेटिव गोल्डबर्ग कंजेक्चर नहीं सॉल्व करना है कि प्रूफ ही चाहिए मुझे, ये चलेगा, कोई प्रॉब्लम नहीं है इसमें. और क्या हो सकता है, ज्यादा नंबर्स है भी नहीं ना. देखो ना 5 और 2 7 नंबर्स है, वो 3 और 4 के ही इसमें मोस्ट प्रोबेबली डिवाइड होंगे. अगर ये नहीं होता तो 5 उधर देख लेते, 3 इधर देख लेते, तो और क्या कर लेते, यही करते. 2-3 ही ऑप्शन है. हाँ 3 डिजिट भी नहीं जाना चाहिए नंबर, 1 डिजिट भी नहीं जाना चाहिए, सो यू ओनली हैड ऑलरेडी हैड लिमिटेड ऑप्शन. तो थोड़ा सा इधर उधर खेल के यही से आ जाता है, कोई इशू नहीं. ये डेफिनेटली आंसर इसमें आता है, बट दिस इज लॉन्गर एंड अननेसेसरीली उसमें तुम्हें कंडीशंस अभी मैं बताऊंगा कि ये डिविजिबिलिटी यहाँ है तो यहाँ पे भी होगी, तो यू विल आल्सो बी कंफ्यूज. दिस इज वेरी इजी. अल्टीमेटली एम तो क्वेश्चन सॉल्व करना है ना, एग्जाम में आंसर आना है. मैथ्स एग्जाम करने के बाद क्लियर कर लेना, पढ़ लेना, अभी तो क्लियर. You can watch yesterday's lecture again, and if you still find it difficult, then you can come to the class and we can discuss, or we can discuss over the phone if you want. But for now, watch yesterday's lecture again. Anyway, फिर नया टॉपिक कल ही स्टार्ट करते हैं ना. It's 10:30. If you have any doubts, आज का लेक्चर चाहिए तो फिर से एक बार देख लो, 2x पे देख लेना यू वांट. नहीं हुए मैं पूछता हूँ मैं उनसे. अच्छा ओरिएंटेशन कल का ही ना, कल का ही हुआ होगा. अच्छा कर देंगे, वो कर देंगे, अपलोड तो कर देंगे वो. आई लेट देम नो. कल का तो यूट्यूब पे भी अपलोडेड है. यू कैन वॉच इट ऑन द यूट्यूब एज वेल. Yes, I'll ask them to upload video time, but yesterday's lecture I think they have already uploaded on the YouTube, that's why they must have forgot about this. Otherwise lectures तो daily upload हो जाते. Yes, yes, यार कल गलती से मैंने सब्ट्रैक्शन इज एसोसिएटिव बोल दिया था. सब्ट्रैक्शन इज नॉट एसोसिएटिव, गलती से बोल दिया होगा, गलती से उसमें भी मेंशन्ड होगा. सब्ट्रैक्शन इज नॉट एसोसिएटिव बिकॉज ये माइनस साइन अंदर जाता है, तो अंदर ब्रैकेट वाली चीज है. दिस माइनस माइनस बिकम्स प्लस एंड दिस माइनस रिमेन्स माइनस. सब्ट्रैक्शन इज नॉट एसोसिएटिव. प्लीज करेक्ट दैट. Very good, Janardhan, that you pointed it out. Subtraction is not associative. Correct. Okay, clear. जो भी आज पढ़ा था, कल पढ़ा था. You're finding it explanatory, मतलब explanation सही पेस पे जा रहा है ना? If you are finding it fast or slow, let me know. tomorrow you'll get worksheet for this particular chapter, वो attempt कर लेना. कल हम लोग divisibility test करेंगे and इस BODMAS rule, then HCF LCM देखते हैं. We are going slow with this particular booklet because ये थोड़ा फाउंडेशन टाइप का है. अगर ये क्लियर हो जाएगा तो बाद वाली चीजें आसानी से क्लियर हो जाती है. एकदम एक एक लेक्चर में एक एक चैप्टर हम लोग खत्म कर सकते हैं इफ वी इनिशियली गो स्लो. वही कर रहे हैं. ठीक है. यू डोंट हैव एनी डाउट्स? हाँ बोलो. आ जा. दिस इज क्यूब रूट ना, क्यूब रूट. हाँ दिस इज क्यूब रूट. हाँ फर्स्टली भूल जाओ कि डेसिमल है. तो क्या क्यूब रूट है? 729 का 9 है तो वो लिख लिया. अब क्योंकि यहाँ पे 3 है तो ये ऐसा कर सकते हैं कि इसलिए डेसिमल पॉइंट के बाद 3 है ना, 3 या 3 की मल्टीपल में चीजें आती है तो फिर ऐसे कर सकते हैं. यहाँ पे देखो 0.9 का क्यूब क्या था? 0.729. यहाँ पे क्योंकि एक पॉइंट है वो क्यूब में 1 + 1 + 1 ऐड हो जा रहा था. 0.9 क्यूब इज इक्वल टू 0.9 इंटू 0.9 इंटू 0.9. ये क्या है? पहले तो भूल भूल जाओ पॉइंट है. अब 1 + 1 + 1 यहाँ पे पॉइंट आया. राइट. रिवर्स जाना है तो यहाँ पे 3 है राइट हैंड साइड में, उधर जाएगा तो 1 हो जाएगा. 3 का 1 हो जाएगा, 6 का 2 हो जाएगा. हाँ हाँ क्योंकि यहाँ पे 1 + 1 + 1 ऐड हो जाता है, यहाँ पे 3 का 1 हो जाएगा. हम्म, वो ऐसे मैंने डाला था जानबूझ. हाँ इन कंक्लूजन नहीं, वो आंसर है. वो आप पूछेंगे नहीं तो. हाँ यही आंसर है. बट ये सब नहीं पूछेंगे. मैंने जस्ट जानबूझ के डाला था कि फंसना मत इन केस अगर पूछे तो यू शुड नॉट बी कंफ्यूज. तो वो क्यूब रूट तभी निकाल सकते हो इस मतलब ऐसे सिंपली. क्यूब रूट तो होगा कुछ, कैलकुलेटर तो तुम्हें वैल्यू दे देगा इसकी. बट इसका इस तरीके से तभी होगा अगर वो 3 के टर्म्स में 0 3 6 ऐसे है. हाँ हाँ. हम्म. हाँ और वो इसका 1 है ना. अज्यूम नहीं. 0.7 क्या होता है? 0.7 इज इक्वल टू 0.7 डिवीजन है ना. माइनस में डिवीजन है. डिवीजन है तो सब्ट्रैक्ट होती है ना. हाँ ऐसे लिख के लागे तो. चलो गाइस, क्लास इज ओवर. गुड डे. इफ यू डोंट हैव एनी डाउट्स, इफ यू हैव यू कैन आस्क.